Hello everyone, I'm Pranshu. Thank you for joining us for today's webinar. We'll just wait for another minute. I can see a few people logging in. We can just give them a few seconds to set themselves up and we can get started. I hope you're all safe and keeping well, and I'm also hoping I'm very audible to everyone.
Yeah, Prince, you're audible. We can hear you.
Yes,
loud and clear.
So I'll quickly begin today's session by introducing Walking Tree for anyone joining us for the very first time. Walking Tree Technologies is a technology-focused company with our core focus on designing and building cross-platform web and mobile applications, perform system integrations, and enable digital transformation. We also specialize in data integration, data analytics, migration from legacy to modern systems, cloud migrations, and of course, perform UX design. Apart from end-to-end application development, we also provide custom solutions to enterprises for web and mobile, very specific services within the software development lifecycle, including UI, UX design, microservices, DevOps, and cloud. Our flexible staff augmentation services provide clients with on-demand skills and resources to help meet organizational and business objectives. Lastly, we also help you to implement certain solutions like objective performance assessment amongst one of many. Today, we have two presenters, starting with Scott, who is our CTO, and he comes with an experience of over 30 years now in engineering enterprise computing systems. These include many years of cloud computing experience with public and private cloud architectures. He's also worked in all phases of software development lifecycle, including product ideation, design, development, testing, implementation, and operations support. He's also helping our clients bootstrap their AWS strategy for accelerated global growth. We also have Shubham with us, who has been with us for almost 4 years now. His core strength lies in DevOps, analytics, AI, and machine learning. He has helped our clients save thousands while moving into AWS and embrace innovation at a competitive pace. That was about us and our speakers. I'll be handing it over to Scott. And before I do that, I just wanted to let you know that this is definitely an interactive session. So if you have any questions, please leave them in the Q&A box. And after our speakers are done, we'd be most happy to accommodate as many questions as possible. So over to you now, Scott.
Okay, thank you very much, Prince. And what I'll do is just start out by taking a look at our agenda. And Prince, if you can move there. Okay, thank you. So, guys, what we're going to focus on today is we're going to kind of take a look at what we call the why and when do we need MLOps. Then we'll take a little deeper dive into the AWS MLOps Framework, and we'll follow that up with AWS MLOps Solution Implementation. So we'll look at a couple different approaches for that. And then we'll kind of end our session with an industry use case, and we'll actually show you the implementation. And if we do all that well and right and timely, we'll hopefully have 10 or 15 minutes left at the end that you can ask your questions. So we'll make sure we leave time for that. So, okay. All right. So let's start out by looking at the looking at why and when do we need MLOps. And the first thing that I'd like to do is maybe step back and even though I didn't put it in the title, let's just kind of take a look at what is MLOps. So MLOps, or machine learning operations, and it offers a managed and scalable means to deploy and monitor machine learning models. Okay, so taking it from just the lab over to actual repeatable, consistent process to deploy and monitor and then optimize those models. So MLOps is modeled really after DevOps. And most of us are familiar with DevOps now, but just in case, DevOps is the practice of efficiently writing, deploying, and managing enterprise applications. And you got players like your developers and your operations teams that are in close collaboration with one another. And, in a similar fashion, excuse me, you've got data scientists who they curate the data sets and then they analyze them by creating AI models for them. And then you've got the machine learning engineers who use automated and disciplined processes to run those data sets through the models. Okay, so just in a very similar fashion with DevOps between developers and operations teams, you got a similar collaboration approach between data scientists and your ML engineers as well. Okay, and again, collaboration. The collaboration is kind of key, right? When we talk about establishing MLOps or DevOps for that matter, and as we'll see coming up, that there are close collaboration points through the different phases of managing our models and really developing a life cycle for our models, right? And then MLOps brings about automation as much as possible, and it really helps us to eliminate waste, and ultimately it produces deeper and more consistent insights for using machine learning. And then just to kind of summarize it, it enables data scientists to really focus on building and deploying models rather than, making business decisions. And it really then empowers the MLOps engineers to manage the machine learning that's already in production. Okay, next I've got a view, and I like this view. It's very similar to the DevOps views you guys have probably seen. And I kind of broke it down into a few phases, what I'll say, use case discovery, data engineering, ML pipelines, and then production deployments and production monitoring. And as we look at that first area, but for the use case discovery of data engineering, the first thing we look at is we got to understand the business, right? And then we identify use cases from that discovery, and then we have to understand the data, and then finally do feasibility studies. So is what we're looking at even feasible, right? And then the next phase of that would be, in beginning the machine learning pipeline creations, right? So we're preparing the data. So we got data scientists, data engineering, MLOps folks involved. They're collaborating, they're preparing data. And then we have to learn the algorithms, and then we do model training. And then finally we experiment with those models. And then really just do the evaluate those models. And if they're okay, then we serve up the models. And then once all that's ready, right, we're ready to get into the deployment phase. So we deploy those models, we have automation around that, and then we execute those models. And then in this process, right, we monitor those models and then we optimize them. And then we repeat the cycle, right? So just a continuous process. It's just like DevOps, right? And when you develop a DevOps practice, we're developing an MLOps practice here. And I like to use that word practice because, that's essentially what we're doing. Is just like if you were a doctor or a lawyer or whoever, you develop a practice over time. So what this does is give us a way to really be consistent in our processes and be consistent and really, again, develop robust models that are truly useful to our business. And well, what are some of the benefits? And next we'll look at those benefits, at least some of them anyway. And that first one is MLOps allows for rapid innovation through robust machine learning lifecycle management. So again, we're establishing a lifecycle for our machine learning models. And then MLOps allows for the creation of reproducible workflows and models, right? And that, again, that's very important. So we're just continuously reproducing. We have a workflow that allows for the monitoring and then the optimizing of our models in a rapid and reproducible way. And then MLOps provides the easy deployment of those high precision models in any location, any environment. And then provides the effective management of the entire machine learning lifecycle. So in other words, as you look at that picture, we have control and management over that whole process, right? So we take machine learning from some abstract theory, and MLOps allows us to really put that into practice in a very consistent way. And then lastly there, it creates a machine learning resource management system and control. So in other words, again, it's really kind of boils down to, it develops a practice for machine learning, for deploying and using those models. And just like in DevOps, same kind of concept, right, is really gives us more of a resource management system. It gives us control over our models, and it gives us confidence in those models. Okay, so hopefully that's a little bit of an overview, and I'm going to turn it over to Shubham, who is one of our senior software engineers and has lots of experience with in the data space. So Shubham, with that, I'm going to turn it over to you to talk about AWS MLOps Framework.
Thanks, Scott. Am I audible?
Yes, you are, Shubham.
Sure. Thanks a lot. Hi, everyone. I'll be picking up from now. To start with, we will see how MLOps is done in AWS. So this whole webinar is around doing MLOps in AWS. Every cloud has their own way of implementing different MLOps solutions, and we will look how AWS does that and what special features AWS provides for that. So as Scott mentioned, MLOps helps you automate the entire ML lifecycle, which makes it more efficient to deploy machine learning models, and it, at the end of the day, helps the entire organization to grow. AWS MLOps helps you streamline and enforce architecture best practices for the productionization of ML models. With the help of MLOps solutions provided by AWS, we can reduce model management overhead by provisioning CI/CD pipelines. When we do this, our teams, be it the team of data scientists or ML engineers, they can effectively collaborate. Data scientists, first of all, will focus on their part of the entire thing, which is designing models. Once they design models, they'll commit their code. The entire workflow is designed as such that once you commit your code, it will trigger a pipeline starting from building of the entire code to the deployment. When you take up this implementation, where the data scientist focuses on building on the code, commits it to his repository, be it his own Git repository or be it the repository is provided by AWS. Once he is done with it, preparing models, next comes the stage where the entire CI and CD process takes over. The models are deployed in the registries provided by AWS, from where, based on the conditions which are put by the QA, they can be taken to production. AWS provides us features whereby we can monitor our models even once they are deployed. So certainly model deployment is not the end game. The very idea behind machine learning is it learns from the word, and as human beings evolve their learning, so do models. And once models are deployed, we need to continuously monitor them. We need to monitor them for bias. It may be that the data that they were trained on is now old. The new kind of data which is coming in for the respective, say, population groups is vastly different. It may be the kind of inference which is being done. The data for which the models are being inferred from, it's different from the original data the models were trained for. So it is important to keep monitoring the machine learning models. Even the features using which the models were trained, they may be less important than the new set of features which we have coming in now. For all those reasons, we need to ensure that our models are kept up to date, and AWS MLOps provides excellent frameworks to be able to do that. When we use solutions provided by AWS MLOps, we are easily and effectively able to track our code, both within our own repositories. We can link them to AWS, and we can track them in repositories provided by AWS. Whatever models we are building, we can have those models stored in the model registry provided by AWS, where we can do versioning, and this provides for efficient compliance and governance. There are broadly two approaches of implementing MLOps in AWS. One is what is known as the MLOps Workload Orchestrator, which I'll discuss shortly. On a broad level, Orchestrator is a framework which allows you to provision any kind of solution that you want. You have an already built model, you want to deploy it, it will give you a pipeline to deploy the model. You have a Docker image, a Docker file, you want to build a Docker image out of it, it will provide you a functionality, a pipeline to build a Docker image. You already have a model in place, you want to deploy a monitoring pipeline for it, it will provide you the monitoring pipeline for it. So it provides you a particular kind of solution, what you need. It orchestrates a kind of pipeline for you, which implements what you need. And then we have something known as Sagemaker MLOps templates or project templates. These are end-to-end templates which are provided by AWS, which cover the entire spectrum from starting from model building to so pre-processing, training, testing, deployment, and then monitoring, retraining. And they provide many more options in terms of configuration. So you can use existing images, you can train your own images, you can build your own images, you can use the model monitor options provided by Sagemaker, all the options provided together or as you want them. I'll come to it. So it's an entire end-to-end solution which is offered by MLOps. Compared to Workload Orchestrator, Sagemaker MLOps templates are more comprehensive, but then there are situations where you will like to go for the orchestrator. There are situations where you'd like to go for the templates. I'll start with the Workload Orchestrator. Workload Orchestrator, by the way, this is a new name. So this name, the Workload Orchestrator, was coined some 2 days ago, because earlier this used to be called as AWS MLOps Framework. And it is why we, in our webinar, we titled it as AWS MLOps Framework. But then this has been the change that they brought in just 2 days before. So this is a service. So this is a framework provided by AWS, whereby we can exercise different options. Users can bring in their own trained models, and they can configure our pipelines orchestration. What I mean by that is, you have a trained model to start with, and you want to deploy that model in different ways. You want to deploy it for getting a real-time endpoint, or you want to deploy it to get a batch job doing inference for you. It provides you those functionalities. It's not necessary that you bring a model from your side and then upload it in the assets bucket, which I'll shortly discuss. You can also use models which are already available, which are already present in the model registry. You can directly pick up those models and have them deployed. It just not only allows you to deploy models, you can, of course, build Docker images from scratch by using your Docker files and the associated artifacts. So you have a Docker file to start with. You can use the model orchestrator to provision a pipeline for you, which will go and build a Docker file. It will build a Docker image for you from the Docker file and the associated artifacts. And then you can use a Docker image, the custom Docker image, and again reinvoke the orchestrator to provision a pipeline which will deploy that model for you. And then you can use the deployed pipeline to further orchestrate a model monitor pipeline, which will monitor the model for you. Let me start with discussing the architecture of the Workload Orchestrator. So as of now, there are 2 implementations of the orchestrator. One is a single account implementation, and the other is the multi-account implementation. The difference is in the multi-account implementation, they have 3 different accounts for deployment of development, staging, and production solutions. Whereas in the single account implementation, all the stages are deployed in a single AWS account. Since right now the focus is on discussing the different features, pipelines which are provided by the orchestrator, I would rather not be focusing on the multi-account deployment, because that is more focus on different accounts for deploying different stages of the pipeline. Here, the focus will be more on the different pipelines as such, which are provided by the orchestrator. So as you see, to start with, this orchestrator is a solution provided by AWS. We deploy it in our account. And when we deploy it in our account, we provided information from different sources. So what is it used for? It's used for deploying models. It's used for building images. We have to have those models available from somewhere. We can make use of an S3 bucket to store those models, or we can make use of models available in Sagemaker registry. It allows us to publish Docker images. Where will those Docker images be published? They will be published in ECR. So it helps connect to ECR. The kind of pipeline we want, whether we want to take an existing model available with us and want to use a built-in algorithm to deploy it, or we want the deployment to be based on a customized Docker image or a custom model, or we want the deployment to be a real-time deployment or a batch job, or we want the provisioning of a Docker, Docker image creation solution. The different kinds of pipelines which can be provisioned by using an orchestrator. All those templates, the templates for those pipelines are maintained in a bucket, which is known as Amazon S3 pipeline blueprint repository. And the way to orchestrate different pipelines there are two ways to do it. One is we make an API call to the API gateway, whereby we specify the kind of pipeline which we want to orchestrate. And by making use of our parameter, which we specify in the API call, and the blueprint repository which it has, where the CloudFormation templates are present, the AWS Lambda function initiates generates a CloudFormation template for the respective pipeline for the respective resource, and then that pipeline is deployed using the code pipeline, which is the CI/CD tool for AWS, the way you have for the way you have Jenkins otherwise. While the pipeline is getting deployed, it picks artifacts from another S3 bucket. So this is the second S3 bucket that you see here is the one where we place the artifacts which we want to be deployed. So we place our models, we place our Docker files, which we want. So what happens is, let me correct. There's a small correction here. So the repository which is used to provision the models, the different kinds of pipelines is this, which I mentioned correctly. Now this is something. These two repositories which I mentioned here, I just missed this. These two repositories, these two buckets are the same, because this is the one which is used to pick up the model or the Docker file, which is finally used to provision the model for you. So this will provide you the template, and within this template, the objects will be picked from this bucket, and finally the deployment will take place. And when you do the deployment, once you have provisioned a model generating pipeline, then you want to receive the data which is generated from the inference from that model, or there are jobs which you are generating. You want the output of those jobs to be stored somewhere. So there we can provision another bucket whereby we want all those things to be stored. We can as well make use of the bucket in which we are uploading our models and artifacts to start with. So let me show that. Here I have the workload orchestrator. This was the earlier version of it was the MLOps solution framework. This was released 2 days ago with a couple of more features, more on the model monitoring side. And this provides 3 buckets to us. 2 buckets are for one of them is for adding the assets, where whichever models, whichever Docker files we want to deploy, all those are added in. So here in this I have the Docker files here. The pipelines which are provisioned get stored here. The details of those pipelines get stored here. The models which I want to provision, they become available here. So they are uploaded by me here for further provisioning. And then whatever data I want to be captured for monitoring, as I'll shortly show, that we store here. So this will become more evident once I show the templates which we use. Another repository which is important is the repository where we actually put our information from which we want to benefit from. Once your model is generated, you want to store the data which is the inference data which is generated by that model. You want to do the data capture. Your models will require some data to operate. So if you have a batch job, the batch job requires an input. For a real-time inference, you can simply call the API and get your output. But if it is a batch job, you need to pass the entire consolidated input you have that you'll store in a bucket, which will be provisioned by you separately. And I, of course, mentioned the main bucket, which is your pipelines repository, whereby you can specify where the entire gamut of pipelines, all the CloudFormation templates are specified. So what you have is the blueprint repository, which I'll be shortly showing. Repository stores all the templates, all the CloudFormation templates, which are used to provision your pipeline, different kinds of pipelines. This is a BOIO approach, bring your own model approach, because you can take models from the registry, but then you can also bring models from your side for deployment. All these templates, the template for deploying a batch pipeline, or for building a Docker image, or for building a data quality monitor, and so on, they're provisioned here. I move on. 4 different kinds of pipelines which are provided by the Workload Orchestrator. You have to bring your own model real-time inference pipelines, whereby you can deploy both models which use built-in algorithms and custom algorithms. You have 2 batch transform pipelines, using which you can deploy models, again with built-in algorithms and custom algorithms. You have an image builder pipeline that you can use to create and register Docker images in Amazon ECR. And then you have model monitor pipelines, which can be used for monitoring your models for which real-time inference is chosen. And when you monitor these models, you can monitor the data which is used for inference, the quality of the data. You can monitor the bias in models. So there are 4 model monitor pipelines which are available. 2 of them have been added recently, as recent as 2 days ago. And so what we have decided now, since they have become an extensive thing in themselves, we'll be covering the model monitor pipelines as part of our next demo, as part of our next webinar, where we will be discussing model monitoring in general. So these pipelines will be covered as part of that discussion. So I show here the way in which we have to invoke our orchestrator for provisioning particular kind of pipeline. What you see here is 2 solutions. One is the real-time one, and the other is the batch one, where you use a built-in model. So on the left-hand side, you have the JSON for provisioning a real-time pipeline, which is based on a model which is provided by AWS. So you are not using a Docker image here. There's a built-in model. It could be XGBoost, it could be linear learner, it could be something else. You mention the version of the model which you want to provision, which you want to use for inference, and then give any model name from your side. You specify the models which you want to deploy from your end. At the end of the day, it's a pipeline which will deploy your model. So you need to specify where that model is. That model needs to be located in your assets bucket, which you configure when you provision the orchestrator, which I showed a couple of minutes ago. But then you need to provide the exact path to that model inside the bucket. You need to specify the data capture location. So since it is a real-time inference, whatever data you are passing to the model, for that you'll be getting some output. The model monitor will require those outputs and the data for processing, for being able to gauge bias and drift. That data needs to be captured somewhere. You'll provide the instance using which the inference will be done. In this case, I've provided as ml.m5.large. And then, of course, you need to provide the name of the endpoint using which you will do your prediction, using which you will actually call your model. On the left-hand side is the equivalent of the same built-in algorithm used framework for a batch implementation, whereby you, as before, provide the name of the model, which is as per your wish. You provide where the model is stored, but then you mention the data which you want the inference to be done for, and you specify the location of the bucket where you want the output to be stored. So this is what I was saying. You have 3 buckets. One is the bucket which will configure, which will provide the templates for you to deploy Other is the bucket where you will store your artifacts for the orchestrator to pick from. And third is the bucket where you will store the outputs generated by the model. In this case, what I did for the purpose of this demo, I tried a couple of different pipelines provided by Sagemaker, as I'll show. The JSON objects which I'll be showing just now, these templates are what I tried recently today, and because they take some time for deployment, so rather than doing the deployment during the course of the demo, I will be showing it from the slides. I'll show how to deploy, but then I'll not be effectively deploying them right away. So what I deployed here was for the real-time inference case, and the built-in model case was a linear learner model, a very simple model which predicts salary based on the number of years of experience. And this model is available in the models folder inside my assets bucket. And I'm trying to capture the data generated, the predictions made, and the data which is actually fed to this model for inference in my another bucket, which in the data capture folder, and the endpoint is named as linear learner. Similarly, I'm making use of the same algorithm, but this time I'm doing a batch processing. I'm doing a batch job. I'm storing my input in my another bucket, the salary.csv file, and the output will be stored in the same bucket in another folder. So this is what I have. What I do is when I have to call this model, the way to first of all provision this pipeline is by making use of this JSON. So I go to my model workload orchestrator. Once I go to the orchestrator, I'm doing it through console. The same can be done via CLI, of course. This is just for easy viewing. So I make a call to the API, to the model orchestrator API via the JSON. This is for actually building an image, but what I showed was for building deploying a model. So once I test it, once I invoke the API, I'm provisioned a pipeline. A pipeline is provisioned for me, and that pipeline effectively generates another API using which I can do inference. So in this case, I was talking about a linear learner model. I used those two JSONs to give me a real-time inference and a batch job solution. So this is what I got. So the real-time inference is here for the linear model. The batch, of course, it doesn't show as an API. It's something which which runs as a job, which I'll show. So for the API, which gets delivered for me, I can directly make a call to it. So here is a sample call to the API. I just give my payload, which is here the number of years, and here's 3. I'll just change it to 7, and this will give me the salary for this use case. I mean, for this figure, I get the predictions here. Similarly, there is a batch equivalent of it, whereby my model was deployed but used for batch inference, and that is what I can see once I have a look at the batch jobs. So batch jobs are these. Let me have a look at one of the batch transform jobs. So this is one of the batch transform jobs which was executed, and this batch transform job, for this, the input data was a churn data set. So this is the second job which I'll be showing. Excuse me for that. The job which I just provisioned by making use of the template was this one, the batch transform job for my linear learner model. And this is using an input which is provided by me from this input data bucket folder of this inference data MLOps bucket. And the output of this is stored in the same bucket in another folder. So what I provided was a CSV for which contained different numbers of different number of years of experience, and corresponding to that, I had an output generated which stored for me the salaries. So I think I have the files already available with me. I'll just show them to you. So you have a salary CSV which contains the number of years of experience, and then you will have an output for the same, which will show the results. Let me actually download it from here. Maybe it's easier that way. I don't have the output here. So this is my output for this batch job, and I'll just download it and show that the entire data was processed in comparison to just one value in this particular case. So again, this depends on the kind of provisioning you want to do. There are cases when it is better to do batch inference, vice versa real-time inference. For each value, you are getting a salary for each number of years of experience. Sometimes we have models for which we do not require availability 24/7. Of course, these endpoints cost, and this time I provisioned them on a large instance, which costs more. So there are situations where we do not need 24/7 availability of a model. We just have bad jobs. We may be doing ETL where we require to invoke our models. They run at a certain period of time, interval of time for a certain interval of time or at a particular point of time. We just have these jobs provisioned at that time and then available. So this is how we provision a simple model using the workload orchestrator. We deploy a simple model using the workload orchestrator. Another is doing the same thing, but for a customized algorithm. You don't use an inbuilt model provided by Sagemaker. You generate a Docker image from your site and you publish it to ECR. Again, you can generate the same Docker image using the Docker orchestrator, as I will shortly show. But first this, once you have a Docker image which you generate or which is provided again by Sagemaker, but it is not an inbuilt algorithm per se, you use it. And what I'm showing here, this refers to the industry use case which I want to discuss. This is the customer churn scenario where which is a very popular business use case. So every business wants to retain customers and wants to predict whether a particular customer may be leaving or not. So different industries will be having their own metrics for measuring customer churn, and in this case the model which I deployed measures those metrics, calculates prediction for customer churn in context of telecommunication business, mobile networks. So what I'm showing here is a custom image where which is an XGBoost image provided by Sagemaker nevertheless, but it's a Docker image. It's not the inbuilt solution like the linear image which I was mentioning earlier. We can of course add more to this image as per our requirement and then push it to ECR. Again, there are two implementations, the real time and the batch one. As I mentioned earlier, for the real time, we can just call it via the API here. So this was the solution which I was showing earlier. This one was for this customer churn use case, and for purposes of just to make it easy. So when I'm doing inference, I'm just, of course, while doing inference, I'm passing it the data as it enters the model, so which is pre-processed data. So what I have is a number of features, so a kind of CSV containing all the features which are there, and for each of these features, for the complete combination of these features, I'm getting one output, and this output is actually the churn probability. So in this case, the customer is not going to churn. If, for example, the features were different, if I were to just change some value, maybe that would change, or maybe it will not change. It will depends on what the value is. So I'll be discussing it when I come to the model in greater detail. So in this case, the probability of churn increases when I increase that value. Then is the third pipeline, which is third major pipeline, which is the pipeline which is used to provision or to generate a Docker image. In this case, you just specify the custom artifacts which you have, the Docker file and associated artifacts, and you specify the repository in which you want the entire image to be pushed, and you provide the image tag, and then you simply execute it. So in this case, I had a Docker file which was used for updating a Linux, I think Ubuntu with some Python version and adding some more packages. I just put it as a zip, the entire artifacts together, put the zip and uploaded it to ECR via just executing this. So it's the same, you take this and you execute it, It provisions a pipeline for you similarly. And once the pipeline is successful, your image is pushed to is compiled and pushed to ECR. So this is the image which I had, which was pushed to ECR by the execution of the pipeline. So it's providing a service that you need. If you want to deploy a model for a particular kind of use case, real time or batch, whether you use an inbuilt algorithm or whether you provision generated Docker image from your side, it does that thing for you. So to start with, you can generate a Docker image, then you can use a generated Docker image to provision a model. You provision the kind of model you want, the kind of the inference you want. And then there are templates which allow you to do inference on monitoring on top of those models. I'm not covering those templates right now because there are a total of 4 templates, 2 of them added recently. So it will be unfair if I just discuss them, because this is just one way of implementing MLOps provided by Sagemaker. Now I'll be coming to the other way, and in the next webinar, we'll be discussing them in much greater detail, because for discussing them, we need to actually cover certain topics like concept drift, model drift, explainability, bias, and so on, which will require some time. So what I've discussed so far is how we do MLOps in AWS using the orchestrator. This is a kind of a function. You pass in a parameter, it gives the pipeline to you. However, in a real life project, you just don't want one thing at a time. There are situations when you want to build a Docker image or you want to deploy a model, but then in a real MLOps situation, you want to do the entire thing. You have your data set to start with. You want to pre-process it. You want to define a model. You want to train the model. You want to evaluate the model. You want to deploy it. In the middle, you may want to do some kind of hyper tuning, whereby you see which parameters are best for use in your model. Once you deploy your model, you need to constantly monitor it. And then you don't do it alone. You have a complete team which is working with you, which is collaborating with you. So different members in the team will be testing their own versions of the model and deploying them seamlessly. For that kind of an exercise, you would rather require a more comprehensive, a more integrated approach, and that approach is provided by a solution, which is the Sagemaker MLOps template, so project templates. So these templates provision the initial setup, which is required for a complete end-to-end MLOps solution, including model building, training, and deployment, and not just this deployment. This stretches to model monitoring and retraining as well. And a typical Sagemaker project, which includes these templates, consists of a code repository. You may use your own GitHub repository for this purpose by linking it to this code repository, which is provided by AWS. So the AWS repository is code commit. You can work with code commit and do MLOps in AWS, or if you want to link it to your repository on Git repository, you can very well do it. There are templates provided for that explicitly. It configures the Sagemaker pipeline for you. Now the Sagemaker pipeline will have different stages. Each stage is independent. All these are different components. Pre-processing is a component, training is a component, evaluation is a component, deployment is a component. So you can work on each component independently as per your expertise or your work in the team. It provisions a code pipeline for you, which is effective, which is a CI/CD framework. So the way you have Jenkins normally in DevOps, here you have the same solution is known as a code pipeline, which does the building and deployment for you. And then once you deploy, your models got to be stored somewhere. And in this case, AWS provides you a model registry, which you use to store your models. There are different kinds of templates which are provided by AWS, and you can choose from them. There are basic templates which allow you to do building of the model, training of the model, and deployment of the model. And if you don't want to do model monitoring, if you don't want to say build customized Docker images from your side, these templates are good to work with, and they'll provide all other benefits of working in a team. But then there are templates which will allow you to do model monitoring because those solutions are integrated in them. There are templates which will allow you to build the image at each step of the process for the inference, for training, for pre-processing. As I mentioned, it's not necessary that when you work with these solutions, you need to stick to just AWS code commit, which is the repository for AWS, code repository for AWS, or AWS code pipeline, which is the Jenkins for AWS. You can very well integrate your own Git with these and work. So there are specific templates which allow you to do that. So what I'll come to now is the demonstration of the customer churn use case. And I'll be doing it via templates because, as I showed earlier, the model which was generated was actually deployed using Orchestrator, but then the entire generation of the model, training and implementation, the deployment, and then pushing to the registry, I'll show here. So I'll be using Amazon SageMaker Studio for this purpose, just to show it up. Excuse me for a while, I think I'm logged out. I shall be logged in shortly. Trying to show you how we can make use of SageMaker projects for doing an end-to-end implementation of our pipelines and thereby our solution. What I show here is a pipeline, is a customer churn pipeline where you have different stages, starting with processing or pre-processing, the training stage, the evaluation stage, and then this is followed by a deployment stage. I'll just refresh it to make it movable. All these deployments have been done by me quite recently in the last couple of hours, because if I were to do them in the call, it would take more time. So as I was mentioning, there are different stages of the pipeline. Where the first stage where you pre-process your data, and each of these stages implemented by via code, which I'll be shortly displaying. You have the training stage, you have the evaluation stage. Once you evaluate your model based on certain conditions, if the accuracy of a model is, say, beyond a certain value, or at least of a certain value, then you go and deploy that model in your registry. And finally, you take the model into production, again based on some condition. The beauty is all these things can be perfectly automated. So they are automated by default. But then if you want to bring in a manual intervention, you can bring a manual intervention by explicitly mentioning that at certain stages you want, for example, manual approval. So from the stage where you push the model to registry to where you do it to push it to production, you can add a manual approval stage, which is there in this case. It's there at 2 levels. So let me show you how it looks like. So you have a churn pipeline where to start with, you do pre-processing of the input data, the customer churn data set, which is in this case, I'm using a data set provided by Sagemaker. This is for, as I mentioned earlier, churning in the telecom industry. And this makes use of each step in the pipeline, makes use of containers defined for those steps. And these containers are essentially, you can say, Docker packages, which provide you the libraries and other frameworks which you require for running those modules, those pieces of code. In this case, I'm using a pre-processing container, which will be based on scikit-learn, so that I can, for example, do train test split for the dataset and generate train dataset, test dataset, validation dataset. This dataset I pass to my training stage, and in my training stage, I make use of XGBoost model with its own set of hyperparameters. So rather than going through the entire code for want of time, I'll just cover the broad themes. I'm declaring the instances which I require for processing. So each step will be done by a kind of job. Pre-processing will be, there will be a job for pre-processing, there will be a job for training, there will be a job for inference. For doing each of these jobs, you require an instance. So the kind of instance you want for these kinds of jobs, that's mentioned in the pipeline definition itself. When you want to do pre-processing, you would like to use one kind of image, as I was mentioning. For other stages of the pipeline, you will be using a different container, different kinds of images. All of them are mentioned in the pipeline. In this case, the model which is used for doing prediction is XGBoost. So it actually helps you assimilate different kinds of, rather integrate different kinds of attributes and get a cohesive, rather integrated output based on those features together. So vice versa, a linear implementation. So here the parameters which are required for implementation or rather the execution of the training step are specified. and then the training step is defined, whereby you take the input from the previous step, which is the pre-processing stage. All these steps, be it the pre-processing step, the training step, the evaluation step, are independent in themselves, but linked to other steps via an input and output combination. This is what a normal pipeline is like. So I actually saw a question where somebody asked me whether Kubeflow can be integrated with AWS pipelines. So certainly yes, because at the end of the day, what Kubeflow provides you is again a pipeline kind of solution, and you can deploy Kubeflow in your AWS cluster as good as doing MLOps here. So then you have model metrics, where you whichever kind of metric you want for your particular model, you store it in an evaluation.json, and it's a standard file evaluation.json, and this file is used further for checking when you are deploying the model. When you're registering the model first and then deploying the model, you check for the condition, and if the condition is satisfied, then the model is taken to the further step of deployment. So this entire thing I'll be rather demonstrating with the help of a slide quickly. The entire process. How do you go about making use of this? To start with, you have a Sagemaker template. When you start Studio, you go to projects, you can create a project, and while creating a project, you can choose one of the available templates, which I was showing earlier. Once you choose a template, you put in your modules corresponding to those components, those steps of the pipeline. Then once you are done with it, the moment you commit your pipeline, in this case, the pipeline, the whole code is committed by default to code commit, which is the AWS Git repository, so to say. Once you commit it, there is an event bridge event which starts the building of the pipeline. The different steps in your pipeline, from pre-processing to training to processing for evaluation, and then to deployment, they are executed, and you end up registering the model. Now, there are cases where before registering the model, you want to put some kind of check, as I was mentioning earlier. Now, this check could be an automated check, which means it is done via a script, or it could be a manual check. So, for example, in this case, it would be again great if I go back and show it via the Studio. When your models are pushed to registry, you have some ways of controlling the further progression of those models. So here you see something as approved. So once this model was pushed to the registry, this was pushed on a condition for accuracy, which was like the model should be accurate 80% in this particular use case. But once it was pushed, then the configuration in this case was, we will take it further only once we approve it for deployment. And there is a status option for that, where you mention whether your model is approved or not approved. Now, again, you need not implement it, because if you want to automate it, you can just rather doing the pending for manual approval configuration, you can just use automated deployment configuration. But then it shows, if your QA is interested in checking the quality of the model, wants to see the accuracy of the particular model, they can have a look at it. And this is the model registry, which stores different versions of the model. So you can see this particular version, and as when I open it up, then you will have the quality of the model. So the accuracy, this depends on what you specified in the template. This is showing the accuracy of the model and the area under the curve associated with the execution of the pipeline. You can configure particular kinds of reports. In this case, I configured none, so they don't show anything, but then this can be done. So once you approve the model, then it can be deployed via the code pipeline to staging and then to production. Now, this is a single account, but then you can have two different endpoints, one for staging and one for production. In this case, we decided to have a manual approval step, because of course production is critical. So your QA reviews the case. So if I show it to you here, there is a manual approval step, even in case where you take it to production. This will be shown in the pipeline itself. log rotate every place. All right, I shall go to the pipelines quickly. So this is the Sagemaker, the MLOps solution for AWS. And from here, I shall be moving to my pipelines. Let me go to my code pipeline. Code pipeline is your Jenkins for AWS. Since we are also in time, I would like to just cover it quickly without going into too much of detail. I just wanted to show you the approval step where you can, by default, you can do it the automated way, which is generally the case, but then for want of more carefulness, you can implement the production approval stage separately, where your QA will first approve it and then it will move from staging to production. This is different from pushing it to the model registry, which you, for example, which you can control through the studio anyhow. So once your model is deployed to staging, you need to provide a manual approval here via this step. And once you provide a manual approval, only then the model is further taken to production. What ends up getting created are two endpoints, one which you use for staging and one which you use for production. So when I was talking about the workload orchestrator, I mentioned that you can do it in the same account and you can do it in 3 different accounts for development, staging, and production. But then within the same account, you can have more than one endpoint, which you can use for different use cases: staging, QA, and production. I mean, development, staging, and production. Finally, I summarize. So AWS MLOps helps us automate ML workflows to accelerate various steps of the lifecycle. And once you automate it, you only need to focus on your part of it. Once the entire thing is automated, you need to focus on your part of it. So if I'm a data scientist and then the entire thing is automated, once I have made a code change, once I have committed it, once I have pushed it, I don't bother. It will get deployed automatically because it's a completely automated pipeline. It facilitates delivery of ML-driven innovation at scale. Naturally, when you have the kind of automated solution, you are very fast in trying different model versions. All those model versions get captured in your registry. You can actually look back at earlier versions and go back to them as required. This enables you to do innovation through ML at scale. If you want a particular kind of very specific kind of solution, you want to just build a Docker image, or you already have a solution, you already have a model to start with, you want to deploy it, you just want to do batch inference, you don't want to write the code, you are not aware of how to write the code, you just have your model, you know that this image can be used to deploy the model, you pick the image, you pick the model, you deploy it. The orchestrator will do it for you. Of course, if you're doing through Sagemaker projects, you need to write the entire code to do it. If you're doing a real time, you'll do model or deploy. If you're doing a batch transform, you will invoke the batch transform function. However, that will also give you much more flexibility in terms of the entire design which you have. By the way, both these, the workload orchestrator and the MLOps templates are extendable, extensible. You can add your own code and then rebuild an entire solution. But then what I focused on is what they provide you right now and how do they compare. As I mentioned during the call, there was one important component which I did not cover for lack of time, and it was a model monitor. I need to cover that both from the orchestrator perspective and from the Sagemaker model, Sagemaker MLOps perspective. So Sagemaker MLOps projects provide you a different template for model monitoring, which enables you to take care of model drift, take care of concept drift, something known as concept drift, provide you the details associated with related to biasing in the model, provide you something known as explainability of the model. So it's a whole big field which we'll cover in the next webinar. Thank you. I'll be picking the questions now.
Thank you, Shubham. You're able to see the questions which are there in the Q&A box?
Well, I can see in the Q&A box.
Yeah.
The first question is, what has Working Tree and AWS seen in efficiency gains or percent or hard numbers with the frameworks? Well, I can't talk of AWS certainly because I didn't go through any figure published by them on this. But then I can certainly mention that since we have brought in MLOps here, we actually don't bother we don't have to perturb our DevOps engineer every now and then. Earlier on, what would happen is whenever you are done with building of a model, you would be dependent on your DevOps engineer for deployment of the model, and then based on his or her availability, it would be done. Now we don't have to do that. So I, for example, as a data scientist or a machine learning engineer, can just focus on the coding part of it, and I just commit it and I see the results for myself. So there's the qualitative change is quite clear. I may not be able to quantize it effectively, but then qualitatively, it's a big jump from dependence on others to just focusing on your work and seeing the results for yourself. How AWS help? Second question is how AWS provide help to create model. Well, as I mentioned, the way to create a model is there are two things. So one is you can use an inbuilt model provided by them. So if you are asking how AWS helps you with modeling, AWS helps you with certain built-in algorithms that you can use for modeling. So for example, if you are doing say fraud detection, so we work in BFSI domain. If you're doing a fraud detection and you want a ready-made solution for it, AWS will provide you for that solution. You can make use of random cut forest, which is the RCA, which is AWS solution for anomaly detection. But then when it comes to building a model from your side, it is something which you do like you would do in any other framework. So when you code it up in Sagemaker projects, you define the model precisely. You define that you are calling linear regression. You define you are calling logistic regression, and you train it. So AWS provides you inbuilt models, and then it, of course, it provides Docker images for them. But then it's not something which will make the model generation part easier for you by itself. Models are generated as per your specific requirement. The third is if I have ML model which is saved in Pickle or JobLib, can I use that saved model here and run the pipeline? Well, I have not executed it for this particular case. I myself will have to test it, but then there is nowhere have I read that this model needs to be in a TIE-zipped format. So ideally that should be doable, but then subject to actual implementation. I'll try it out and the user may reach me separately for this. How to generate a pipeline from the ML code in the MLOps orchestrator? Well, so the MLOps orchestrator provisions a pipeline for you. It provisions a pipeline for deploying model, for real-time or batch, for generating a Docker image, for deploying a model monitor. Now, if you, for example, want to do an end-to-end solution, so you have your Docker file, you create a Docker image by using the Docker pipeline, then you use a Docker image by using the model deployment pipeline, then you use the model deployment pipeline to do the model monitoring. You can make use of those steps independently. You can make use of those pipelines independently. So it's like the solution is meant for providing a particular kind of service. Now you want to make use of this for implementation of a complete end-to-end solution, then you'll have to implement it in parts. That is one way. The other way is they provide templates which you can customize. There is the entire thing is present in a repository which you can find, and then you can add your own CloudFormation templates for the pipelines, which I was showing were present in Blueprint repository. You can compile them and do it for you. But then I would say that's a more, if you want to do it the easier way, better do it through projects. Does AWS, the next question is, does AWS SageMaker provide model deployment to Kubernetes out of the box and capabilities such as canary deployment, A/B testing, and third-party integration for monitoring or tracing? So third-party integration for monitoring or tracing. Well, AWS certainly provides you integration with Kubernetes. So you have something known as Kubeflow, which you can integrate with your AWS. You may have a solution running in AWS, a cluster, in EKS cluster, and rather than actually implementing AWS pipelines, you can implement Kubeflow pipelines in that solution. So that integration is provided. Whether it allows to making use of third-party integration, third-party services for monitoring. I haven't come across those. So I have come across AWS provided solutions for monitoring, which is your model monitor, but I'm not aware of whether it allows for third-party integration. I'll have to check it myself. These were the questions which I had in the question and answering box. Now let me look at the chats. Is AWS MLOps linked to Kubernetes? Yes, I mentioned it does. Of course, you can integrate Kubeflow with it. What skills are required for MLOps? So it's a very generic question. Since MLOps is both ML and operations, you need to have some basic understanding of ML. You of course cannot do all this if you do not know how to tackle models. But then you need not be a core ML guy, because for example, if there is something wrong in your model, once the model is deployed, the model is not doing the correct prediction, it's not your business to, it would not be your business to go and check the accuracy of the model. The data scientists will be involved in that. So some experience in ML will help. But then what is equally important is being able to understand and appreciate the entire workflow and execute it, which is an independent skill from ML, which actually comes from a DevOps kind of experience. Can we do champion challenger deployment for models with this framework? Well, can somebody elaborate what this champion challenger deployment is? Somebody may put it on chats. I'm not aware of this. Meanwhile, I'll come to the next question. One challenge is Kubeflow need to install manually. Bias report. How you can show CloudWatch meanwhile. Somebody is mentioning about bias report and A/B testing of reports. As I mentioned, all these things which are related to biases, drifts, and so on, all the reports which are produced by Sagemaker related to your models for monitoring, they'll be discussed by me in the next webinar, because there's an extensive, there's a comprehensive topic in itself. So I was just asking whether the person Ramkrishnan can talk about champion challenger. 80% requirement go to V1 model and 20% requirement go to V2 model. Well, I don't think so, because this is an orchestrator. So an orchestrator is not, it's not your load balancer. It's not taking your request and moving to one model or the other. This is a solutional provisional for you. It will provision a deployment. Somebody says that's possible. Now, strange. I would like to know how it is, because if you just talk about orchestrator, then the orchestrator will be used to provision your model, to deploy your model, rather than to just do load balancing on your model. So if you want to do load balancing, you'll have to do a different setup, which is different from the orchestrator. If that setup is done, that will be done outside the orchestrator framework.
All right, thank you, Shubham. I think that's all the time we have today. If there are any questions, please do reply to us on the same mails that you have been receiving the invite for this webinar. We'd be most happy to get back to you with if anything you feel we have left out. But as Shubham has already said, we will be covering quite a few of your questions in our upcoming webinar. So please stay tuned for that. We'll be reaching out to you for the same. Thanks a lot, Scott. Thank you, Shubham.
Yeah, thanks everyone. Thanks, Shubham, and thanks everyone for joining.
Thanks, everyone.